In this video, I'm going to go over some tips that you can use in a technical interview. I'm using Java as an example, but a lot of these can be applied to other languages as well. So, overview, first some assumptions about the interview, what to do if you don't know the answer, some common questions and common concepts you're likely to face. Now, I'm coming with a little bit of experience here. I've probably given 100 or more technical interviews where I'm interviewing someone, and I've probably taken about 100 or more technical interviews myself where I'm the one being interviewed. So this isn't meant to be a comprehensive list. There could be other things, and you never know what's going to happen in an interview. But across all of those interviews, these are the themes that I have seen. So start with some assumptions. Don't assume the interviewer has read your resume. The interviewer might not have time, or it might be one thing that's happened a lot to me, which is I'm walking back from lunch and our HR department says, Brandon, quickly, can you take this interview? Someone else just dropped out and the candidate's already in the room. And sometimes I walk in with absolutely no knowledge of who the candidate is and no time to read the resume. So if you're going through the interview and you have something you really want to highlight on your resume, be sure to highlight that verbally and say, boy, I was in this open source project and this is what happened. Don't assume they already know that, or they might have even read it and they might have forgotten. Now, when you're asked a question, the correct answer might not be what the interviewer is looking for. It might not be that important. It may be your approach to the answer. Do you say, I don't know, or do you kind of reason through it and maybe say, well, I'm not sure, but this is what I would go with. Or, I really don't know, but if I had that situation, I would go to something like Stack Overflow or YouTube or something like that and look it up. What is your approach if you don't know the answer? Also, how are you at communicating? Are you one who looks at the floor and doesn't want to be seen, or are you making good eye contact? Are you clear? Are you enunciating? Do you drag on too long, or are you concise? And it sometimes, honestly, probably 1 out of 5 interviews I've taken myself. Sometimes I have the impression that the interviewer is pushing my buttons. In other words, the interviewer is putting me under stress to see how I'm going to react. Am I going to snap, or am I going to be calm about it? Am I going to be, collected about my answer? So keep in mind that it might be a stress test. And to be honest, that sounds kind of mean, but it's very understandable, because if you're working for a company that is selling software, a lot of times the company that is buying software is going to put you under the same stress. They're going to push you and see how far you go before you can crack. So just be aware of that. Okay, what are some things that we're looking for in an interview? A lot of times, a self-starter, someone who is low maintenance. In other words, I'm a manager, I have 14 direct reports. I'm going to add a 15th person now. Is that someone who is going to come and ask me questions all the time that are questions I can't answer because they're too vague? In other words, I'm getting an error, it won't start. Or is this someone, when faced with that scenario, is going to do his or her own research, try to come up with what a solution might be, and then come to me and say, boy, it won't start, I'm getting an error, the error is null point or exception, I've done this research, I think it's this, can you just validate that for me? That second question is a lot easier to answer than the first question, because I know that this person has gone through and done his or her own research and is just asking me something very precise, where I don't have to go through and figure out what the problem is and say, well, what's the error that you're getting? So that's a really good thing to show off. When I was interviewing in college, a lot of times I would talk about a situation where I was given a task and I locked myself in a room and the task did not make any sense, but I just kept trying at it until I found the answer. Now, on the flip side, you don't want to go too extreme there either. You don't want somebody who is going to be too proud to ask a question and is going to waste 3 days in something that a colleague could answer in 5 minutes. So there's a lot of importance about when to ask a question and how much detail. Do your research, but if you find yourself spinning the wheels, then call out for help. Another good quality is someone who's passionate about technology, not just in it for the money. So someone who likes to do things like write apps on the side, or maybe work with nieces, nephews, something like that, and show them how to program, something like that. Good ideas are always important, but a lot of times a company will have a framework that they want you to work within. So they want someone who's going to come with a lot of good ideas and a lot of innovations from the outside, but then not kick and moan and complain when shown an existing framework that that company might have spent millions and millions of dollars building, and they're not just going to rip out and redo because they hired somebody new. So good ideas, but I'm willing to work with what you have, make the best of it, make it better, but maybe not rewrite it and replace it unless that's what you're asking me to do. If you don't know the answer, be honest. I can't stress this enough because as an interviewer, will typically have a 30-minute interview slot and I'll have 50 minutes worth of questions to ask. Now, you're going to prefer that I ask you the questions that you know about, not the ones you don't know about. And I will do that if you tell me when you don't know something. So if we get to a question like, what's your experience with threading? And you say, you know, I haven't used threading. It sounds very interesting, but I haven't used it. Then I'm going to say, okay. And I'm going to skip the next 5 questions on threading. And the next subject might be swing. And maybe you spend a whole lot of time doing swing programming, so we get to explore that in great depth and you really get to show off. So don't be afraid to say you don't know something. Admitting a little bit of humility is better than making something up and getting caught. Because if you admit that you don't know it, we'll spend more time on what you do know. A lot of times when I'll ask a question, they'll come in pairs. So the first question is a question that's fairly easy, and then there's a follow-up question to see how well you really know that first question. So an example, what do you like about Java? A lot of people will say, oh, it's multi-platform. Well, the follow-up is, when have you written a program and run it on multiple platforms? A surprising number of times people will say they've never done that after they say that's their favorite thing about Java. Similarly, what do you not like about Java? A lot of times people will say something like, there's nothing I don't like about Java. Well, I would look down on that, to be honest with you. I've been married for 10 years and I love my wife. But when you know someone for 10 years, you tend to find their quirks. And if you've worked with Java enough or whatever language you're interviewing for, you'll learn its quirks and you'll learn some things that you would like to improve about it. Another thing is people will say to this question, what do you not like about Java? They'll say it's slow. Well, first of all, I argue with that. I say that that's not a limitation of Java. Java doesn't have any significant performance disadvantages to another language. But more importantly, if you're telling me that you write slow Java programs, then you're probably not somebody who I want to hire. So think about something you really don't like about Java, because the next question is, how do you work around that limitation? Now, if you really did say Java is slow, which again I disagree with, if you really do say that, how do you work around that limitation? A good follow-up might be, well, I use threads. Threading increases performance because as I'm waiting for the user to do something, I can do housekeeping in the background, or I can be downloading data while the UI is still interactive, something like that. So remember that a question is likely to have a follow-up, and when you're providing the answer, get ready for the follow-up as well. Okay, for object-oriented concepts, we're going to go through each of these in more detail in the following slides. But you're likely to hear a question about what are concepts of object-oriented programming. Remember this acronym I've made up, API. So abstraction, polymorphism, inheritance, and encapsulation. These all sound like really big words, but honestly, they're all things we've gone through this semester. And if you want more experience, I'll be happy to, or you want to review rather, I'll be happy to put video links to each of these concepts in the summary notes for this video. But rest assured, we've gone through every one of these things this semester. First is abstraction. And abstraction means we want to think of the concept of something we're modeling in real life and not worry about every variation of what it could possibly be. It's a good way to deal with complexity. In other words, in your programming assignment, you are tasked with making an account, a bank account. Now, if you go into a bank and you say you want to open an account, they'll typically say checking, savings, or CD. So you see, they're giving you more complex options than what you said, but there's no such thing as just a generic account without specifying that it's going to be checking, savings, or certificate of deposit. In our in-class example, we've done something similar. We've created this abstract concept of a vehicle, which we're calling vehicle. And all we're declaring here is gallons of gas, miles per gallon, and odometer, an abstract concept. Now, if I go to a car dealer and I say I want a vehicle, they're going to say what kind. So you see, then we get a little bit more specific. But we have defined the abstract concept of a vehicle, and we've set that up as a framework so that we can further define this into a Cavalier, which is a pretty simple vehicle that can also be a convertible, and a Prius, which has a whole lot of complexity because that can run either with the internal combustion engine or it can run with the battery. Now, we don't have all that complexity in this abstract concept of vehicle. That's okay. We've put the complexity where it belongs. We've put the complexity in the subclass called Prius. So that's abstraction. Polymorphism. Wow. This is one where a lot of people know what it means, but they don't know the word polymorphism. And to be honest, if I ask this question, if I say, what is polymorphism? And the interviewee says, I don't know. A lot of times I'm going to assume that the interviewee actually does know, just doesn't know it by this word. So a lot of times the next question I'll ask will be, okay, tell me what happens in this scenario. If you get the question, what is polymorphism? The best way to define it is with one line. And I've broken that one line into two different bullet points here. A variable type tells you what methods you are allowed to call, and an object type tells you what will happen when you call that method. If you want to remember this, an easy way is variable type tells you what methods you are allowed to call or able to call. Able, very able. Object type tells you what happens when you call the method. What is the objective of that method call? Okay, also remember object type can be the same as the variable type, or it can be a subclass or a class that implements an interface of the variable type. Okay, so let's take a look at that. If we go to my driver here, we'll go to my driver class, and what we're going to see is that we prompt the user to create a car, and if the car is a Prius, then it has that little caveat where it might be consuming gas or it might not. Okay. Now, if we go down here in my program, and I'm not going to run this example just because I have several videos that already do, and I'll refer you to those videos if you're curious. But if we take a look at the program, we're going to see we see create vehicle, and we see right here this vehicle.go. So in this case, we're calling a method called go on a variable of type this vehicle. Now that variable of type this vehicle, the variable called this vehicle is a variable of type vehicle. Okay, vehicle is that abstract concept that is extended into Cavalier, Neon, and Prius. So here's the crux of the question. When I call the go method, and the variable is a variable of type vehicle, but the object is an object of type Prius, which go method runs? The one in vehicle, which we've defined here, or the one that's in Prius, which we've defined here. And this method accounts for the fact that a Prius can run with a battery or internal combustion engine. Which one of these is going to run? The method in Prius overrides the method in vehicle because it has the same signature. And by the way, don't confuse overriding and overloading. That's another common interview question. Overriding means two methods with the same signature. Signature is access modifier, return type, method name, and parameter list. One of those methods is in the superclass, the other method is in the subclass. This concept of overriding plays well into polymorphism. But before I go into that further, overloading is a different concept. Overloading means we have the same method name for multiple methods. but the parameter list is different. You're likely to get that question, and it's easy to confuse override and overload. Overriding means same signature superclass and subclass. Just be aware of that. Overriding polymorphism, these two concepts go together. In any case, we are overriding the go method in Prius here, which means if we have an object of type Prius and a variable of type vehicle, the overridden method in Prius is the one that will get executed. Okay, we see that also with the toString method. Remember that toString is defined in that superclass called JavaLang object, which all Java classes will eventually extend. So all Java classes can have a toString method, and that toString method is overriding the toString method of java.lang.object. So that's polymorphism. Inheritance. Okay, if I extend a class, and that class has a non-private method that I do not override, I inherit that method. So let's go back to our vehicle example again, and we just saw how the Prius extends vehicle and overrides the go method. Let's take a look at Neon, where Neon is kind of like just a very generic car. There's not much to a Neon. You see that within the Neon, we are overriding the toString method of vehicle, but we are not overriding the go method. Okay, what happens then, back to our driver, if this vehicle, instead of having a Prius object inside of it, it has a Neon object inside of it? If that's the case, we are going to call the go method in the class called vehicle. And the reason is that the Neon does not override that go method, or in other words, does not give it its own, does not give it a separate implementation. If we do not override a method in a subclass, and that method in the superclass is not private, which is this access modifier here, then the subclass will inherit the method from the superclass. In other words, the subclass will be able to use and call that method from the superclass as if it were the subclass's own method. So that's inheritance. Encapsulation. Okay, you might recall when I was talking about this, I talked about a concept in plant life called stomata. So stomata are these specialized cells on the leaf of a plant that are operated by turgor pressure or water pressure. And essentially, when there's enough water pressure, it inflates these cells, kind of like inflating a balloon. It inflates these cells, which opens it up. When the cell is open, it lets water vapor out of the leaf. That water vapor creates a vacuum within the circulatory system of the plant. That vacuum is what sucks minerals and nutrients from the ground up to the very top of the leaf. Minerals like hydrogen, nitrogen, and magnesium. Magnesium is required for chlorophyll. So if you look at the top of a tree and you see a green leaf at the top of the tree, that green that you're seeing is magnesium that originally came from the ground via water vapor, via this vacuum. We have a very similar concept in object-oriented programming, and that's called encapsulation. And what encapsulation means is if I have a class like vehicle again, I have its internal components, which would be essentially the steam or the water that's within a plant. And that plant has the stomata, which controls access to its internal water. Similarly, we have these private or protected internal variables, which we'll call fields or attributes, and they are accessible via getters and setter methods. So the getter and setter methods act like the stomata, which are given control to our internal variables of this object. The reason why that's important is that we want to understand why gallons of gas is 10 or 20 or 30. We don't want someone from the outside world going in and changing or mutating that unless they do it through a proper mutator method, which would be a setter method. And in that setter method, we can do any kind of security checks or controls to say, wait a minute, you couldn't have more than 25 gallons of gas. You couldn't have miles per gallon greater than 100. So it can kind of put these controls there. Or you can't set a negative gallons of gas. So that's the concept of encapsulation. private member variables or fields or attributes, we tend to call it any of those words, and then a series of getter and setter methods that are public that open up those variables to the outside world, but open them up in a very controlled way. Okay. Another common question. So that was the API: abstraction, polymorphism, inheritance, encapsulation. Another common question: how would you approach this problem? So we're looking at a design pattern here. I have a video, actually a couple of videos, one called Design Pattern Examples Part 1, Interfaces, Command Pattern, Factory Pattern, and then also Interfaces, Abstract Patterns, Abstract Classes, Design Patterns in Java Part 2. These two go together, and they're essentially based around this problem statement. Write a program that processes files. The files are deposited into one directory. The files can contain information about one of the following: employee payroll, life insurance bills, annuity payments. There may be 0 to many files of these types in any order, so on and so forth. So this is a problem statement, and what I'm looking for here is a design pattern that's going to come out of this. Now, in this case, the design that I came up with for this problem set essentially looks like this: some kind of program that controls everything that's running, then either an interface or an abstract class that uses that concept of abstraction, and then one class for each of the different types of files that can be processed. That way, if we add another type of file, all we need to do is add another class. We don't need to change any of the overhead that's up here. That's kind of how I drew that out. And I think that's what this kind of question is looking for, is given a problem set, would you be able to design, not implement, not necessarily write code, but would you be able to come up with a design that shows that you understand the concepts of object-oriented programming: abstraction, polymorphism, inheritance, and encapsulation? And this one certainly does. We have abstraction up here. We have polymorphism as exhibited by the classes that are extending or implementing this interface, or this class over here. So abstraction, polymorphism. Encapsulation, we have the variables declared here, and then I don't have them listed here, but we have getter and setter methods. And then also inheritance. An employee may or may not be a customer, so we don't need to set up an inheritance hierarchy there. But a life insurance customer and an annuity, those are both customers. So we are going to have some kind of abstraction here where we can take things like first name, last name, address, put them into a supertype called customer, and then extend that supertype into life insurance and annuity. So do a bit of reading on design patterns. Nice thing on design patterns is that you can say a name and the person interviewing you will more than likely immediately know what you're talking about without you having to describe it. So if you say command pattern, factory pattern, model view controller, so on and so forth, that will typically ring a bell with your interviewer. But be prepared, because remember that a lot of questions are going to come with a follow-up. So you might want to think, what's this person going to say or what am I going to say if this person asks me to describe it? When I ask for someone's favorite design pattern, I'd say probably 80% of the time they'll say model view controller. My follow-up question then is, describe the controller. Honestly, for an interview, I think model view controller, while it's a very fundamental pattern, probably one of the worst examples to bring up, because the controller is sometimes very hard to explain. Command pattern, factory pattern, those are patterns that are very easy to explain. And again, I have a video that covers that in more depth if you're interested. Something else you might see in a technical interview is find the error. Take a look at this. What kind of errors do you see? I put several errors in here. You see that int has a capital I right here, should be lowercase. This should terminate with a semicolon. Those are some obvious ones. Double equal. We almost never want to use that with a string, because what we're comparing there is the object under the covers. We're not comparing the contents of a string. We should use the dot equals method or the dot equals ignore case method. That's a big no-no. If we're looking at a primitive, that's okay, but a string is not a primitive. One more that's a little bit subtle here. is down here on this line, answer is out of scope. We're declaring the variable here, and remember that a variable is alive from the point at which it is declared until the closed curly of the block where it is declared. While it's hard to visualize here, the word answer down here is outside of scope because the block ended right here. The block doesn't end here, the block ended right here. So the proper thing we would need to do is take this statement and move it before the do while. Then inside the do while, we might put in something like, some kind of prompt. Do you want to continue? You could name several other things that could be improved about this method. Obviously, it's not doing anything useful, but that's really not a syntax error. We could also say no Java doc. So there are several things in here, from the very obvious, like the lack of semicolon or the capital I, to something that you should know, which is the double equal, all the way to something that's very subtle, which is the location of the declaration of this variable. Okay, one other you're likely to have is Java pass by value or pass by reference. The best answer I heard to this is it depends on who taught you. You can get a room full of experienced Java developers, and they will argue over this very question. What this means is if you are passing a variable to a method, and that method changes that variable, what is the effect on the original variable that was passed? This is best to describe with an example, and here again I have a whole 7-minute video that shows that example. I'll point you to that instead of replicating the whole video here. But the short story is, it is passed by value, but object variables are references that are passed by value. That is utterly confusing. Let me just quickly show you the example that I created earlier. If we take a look here, I have this method main. We're declaring a variable called neon and assigning an object to it, declaring a variable cavalier and assigning an object to it. Then we have two primitives, one called first trip, the other called second trip, and we're passing these all into a method called move vehicles. And the method called move vehicles, we are reassigning the primitives. This will have no effect on the variables declared up in the calling method. Reassigning the variable down here will not change the value up here. Okay, cavalier, we are assigning it to a new object. This will not affect the cavalier that's declared in the original calling method. Now, neon, on the other hand, we are not reassigning it. In other words, you do not see an equal sign here, but we are invoking methods on neon. That will affect the neon variable up here. Let's go ahead and run this and see what happens. Neon gallons of gas 40, odometer 40,000, cavalier 20, 20,000, trip 1, 100, trip 2, 200. This all was printed right here in the main method. And if you take a look, the neon, we started at 10, is now 40. The cavalier stayed the same, first trip stayed the same, second trip stayed the same, 100 and 200. The only thing that changed was the neon, and that's because we're invoking methods on this neon that was passed in. We did not reassign it to a new object. That's the key there. So easier to explain that one than to give it a quick answer. That one is a trap. This question is one that's a gotcha. I'll refer you to the full video if you want to see that in more depth. Okay, finally, what is your resume? When I was in college in the late 90s, we would have a resume, run it down to Kinko's, get it printed on resume bond paper, maybe print out 100 of those and then go to a career fair. That's really not the way it's done anymore. Your resume is your GitHub repository. What people can see, the work that you've done. This shows that you're passionate about the technology, which is something we discussed earlier. Anything you've done on Stack Overflow or YouTube or any other social networking site where you have helped someone else out, especially publicly. These things sell very well. And if you've done anything for open source, by all means mention that as well. So resume isn't something that you've written down on a Word document. It's really the proof that you have worked with this, you have helped others, and that you're passionate about the technology. It's something that if I'm interviewing you and I have my laptop with me, I want to bring it up and see what you've done. So I hope this has been helpful. Good luck. Thank you for watching.